Okay, in the video that we just saw, we saw a power balance demonstration. So our power balance bracelets were big for a while, and they were to, like you saw, to help you with your strength, flexibility, et cetera, et cetera, et cetera. Now, I want you to think about this. We're going to talk about the importance of research. So number one, I want you to compare this idea of research to just a testimonial. So what if somebody just said, hey, you know what? I wear this power balance bracelet, and you know what? It really works. Okay? Now, that is a source of information. That's true. But there's several problems with that source of information. One of the big problems is the idea of comparison groups. We have nothing to compare it to. So somebody said, hey, you know what? I tried it, and I put it on, and I felt great, and I did wonderful, and it was wonderful. Well, we don't really have anything to compare that to, okay? So we don't have a comparison of, a group of people who wear the bracelet to a group of people who don't. Or, like you saw in the video, a comparison within the person. That is, I tried this test, this balance test, without the bracelet and then with the bracelet. That would be a comparison group. In fact, what you saw in that video was an experiment. That was an experiment. That experiment is better than just a testimonial. Some guy saying, by the way, like Shaquille O'Neal, for example, was Power Balance paid spokesman, and he's like, yeah, this thing really works. Well, it's better than that because it can show a comparison. It can show the comparison between before they had their balance before they had the bracelet on compared to after they had the bracelet on. Research uses those comparison groups, either one full group, like a control group compared to an experimental group, or the same people in one condition and then the same people in a separate condition. We also use probability in research. That is, what is the probability of this result happening by chance? We're not looking at, hey, this definitely proves anything. Remember, we don't say prove. We're looking at what is the probability that this happened by chance. I don't know if you remember in 2111 or stats class when you were talking about rejecting or failing to reject the null hypothesis. This is kind of what we're getting at, the idea that what is the probability that this would have happened randomly by chance. So for example, if you woke up one day and you're like, hey, I'm going to wear this power balance bracelet, and then you find out that suddenly you have more energy and are able to run longer. So what is the probability of you being able to have more energy and run longer if it wasn't the power balance bracelet that was doing it? So research uses the comparison groups and the probability. Now, even with that, though, many of you still don't believe that the power balance bracelet is the one that's actually making it work. Well, that's because of confounds. This is a confound. A confound is an alternative explanation. So, for example, what we saw in that video, that was actually an experiment. It really was an experiment. I'm not lying about that. That was an experiment. But it was not a very good experiment because it had a lot of confounds and then bias we'll talk about in just a second. But a confound is an alternative explanation. Why is it that the guy did better when he had the power balance bracelet on, compared to when he didn't have it on? Well, there's a lot of alternative explanations. Maybe he was trying harder when he had the power balance bracelet on. Maybe the guy was not pushing as hard when he had the power balance bracelet on. Maybe the fact that he always did the power balance the second time, that is, he always wore the power balance the second time he tried it out, he did better because he had practiced. Practice becomes a confound. Confounds are alternative explanations. Just because something is research, so just because something is a scientific experiment, doesn't mean that it's a good one. A good experiment tries to get rid of those alternative explanations, those confounds. A good experiment also tries to avoid bias, bias in interpreting the results, bias in the experience of the actual study. So for example, we know that both the people in the video that you saw were being paid by power balance, right? Are they biased? Yeah, they're biased. So the bias could come in a variety of ways. Often bias is just, hey, this is what I think should happen. And so the researcher has a bias because they do something because of that bias to change the outcome. Or their bias could be in interpreting the results. Oh, that guy obviously did better in his balance my subjective opinion is he did better with his balance when he had the power balance bracelet on, not because he really did, but because he's biased. Or that there's bias in the way that we interpret one thing that happens or doesn't happen. Things like statistics are meant to help control for that bias. Now, there's other ways we do bias, and I'm not saying that statistics can't be biased. That's not what I'm saying. But we're trying to look at pragmatic, empirical, real life, concrete ways of looking at things that don't include the bias. And we'll talk about ideas of double blind and other things later on, try and control for those ideas of bias and the potential confounds that can come from the bias or from other sources as well. So what we're going to do now is we're going to answer a couple of questions about some potential research questions, and whether it's a confound or a bias, and whether we have a comparison group or whether it's based on the probability. So okay, when we're looking at this love potion example, we are looking at whether or not, first of all, there is a comparison group. If everybody in the group takes the love potion, then we don't have a comparison group. Everybody in the group takes the love potion, we don't have a comparison group. Well, why does that matter? Well, that means that there could be confounds. There could be other reasons, other explanations as to why people, improved in their love. It could be that maybe they just became more mature. It could be that maybe there was other historical things going on. It could be a lot of different things. So there needs to be a comparison group. Everybody cannot take the love potion unless each individual person is being tested on their love before they take the love potion and after they take the love potion. Now, ideally, you change the order of those things as well. You need to be able to have that good comparison group. Probability in this case would have to do with the idea of what is the probability that somebody would fall in love more without the influence of the love potion. It wasn't the love potion that was doing it, it was something else. So even though we gave them the love potion, is there a big probability that they would have fallen in love anyway, right? So what is the probability that somebody would fall in love even if it wasn't the love potion that was doing it? In this case, the idea that you would fall in love without the love potion would be a null hypothesis, right? So we're talking about the idea of the probability of a null hypothesis happening. Okay, so there's several different confounds that we can talk about here, right? So confounds can be a lot of different things. Maybe a confound was the fact that they had a different outfit, right? When they were using the love potion, they were wearing something different. Maybe a confound could be that it really wasn't the love potion, it was the fact that whenever they had the love potion, it was nighttime, compared to when they didn't have the love potion, it was daytime. There could be several different confounds. Those are alternative explanations as to why the results came out the way they did. Bias in this particular case can come out a lot of different ways. So for example, bias could be the fact that there were observers trying to determine how much in love somebody was, right? So an observer would go in there and say, oh, well, those people just took the love potion. Oh, I think that the way they're looking, I think they're really in love after all, right? That would be a bias. They're not objective. They're interpreting it based off of what they want to happen, and that is a bias.